All right, guys, good morning. Happy Wednesday. I'm feeling a little bit sick today, so we're going to do notes from a video, and I should be back tomorrow. So if you have any questions today, I want you to make sure that you are writing them down off to the side. That way tomorrow when I'm back, we can go over those. But today's goal is going to be to do a little bit more with radians, where we are trying to convert from radians to degrees to radians, all that kind of stuff. So just getting really comfortable with that conversion, just like we would convert, like I said yesterday, between a foot and 12 inches, right? It's the same way to measure something, just with different units. So we have some formulas that we can use to convert from radians to degrees. And it looks a little bit like this, where we're taking our angle and multiplying it by 180 over pi. And really what we're multiplying by, this thing is actually just equal to a 1, because remember we said yesterday that 180 degrees and pi landed in the same spot, right? When we picked up our radius, we could always fit 3 radians plus that extra little bit, that 0.14, in half of a circle, or in 180 degrees. So when we are multiplying, right, we're really just multiplying by a fancy looking 1. And we're doing the same sort of thing when we're multiplying to get from degrees to radians, except for instead of doing 180 over pi, we're going to do pi over 180. And so the way that we kind of know which one we want on top, whether we want the 180 on top or the pi on top, is kind of figuring out, well, where are we going? If we're starting with radians and we want to get to degrees, that typically means we don't want to see any more pi's. So if I have a pi on top of my equation, I'm going to want to multiply with a pi on the bottom of my equation. So now those would cancel out, right? That's typically how we would know. Same sort of thing with if we're converting from degrees to radians. We do want pi's now if we're in radians. So we would want our pi on top and our 180 degrees on the bottom. And notice here, if we're thinking about units, you guys have been doing this in chemistry, degrees on top, degrees on bottom cancel, and we're just left with radians as our unit from that top section. So let's try some of these out. We would take our angle, and if we're trying to get to degrees, we want to get rid of our pi, which means we're putting pi on the bottom and 180 degrees on top. And the easiest way to go about solving this would be, well, pi's are gone. And now multiply across the top and the bottom, right? We would have, and we can do this in our calculator too, 7 times 180 on top divided by 4. So if we go over to our calculator, 7 times 180 from the top divided by 4 on the bottom means that that angle is the same as 315. 315 degrees. All right, same sort of thing over here, right? We don't want pi anymore if we're trying to go to degrees. And so the only way we can cancel out a pi from our numerator is if we have a pi in our denominator. So we'll put that 180 up top because these are equivalent. We're really just multiplying by a 1. Our pi's are gone. And now we have 1.4 times 180. So back to our calculator, 1.4 times 180 gives 252 degrees. So not something that we would find on our unit circle, but still how we would convert. All right, going backwards, right? Thinking about this. If we want to get to radians, we don't want degrees anymore. So this little degree symbol on top needs to cancel with a degree symbol on the bottom, right? We have a degree on top and a degree on the bottom. Now our units are gone. And so we're just going to be left with that pi on top. So same idea as before. If we multiply across our numerator, we have 36 times pi. And in our denominator, we could put that over 1 just to make it a little easier for our brains. We have 1 times 180. And we do want to simplify this down a little bit, like thinking about if this pi wasn't here, what would 36 over 180 simplify to? And our calculators are actually really good for helping us do that. So if we go back to our calculator and we type in 36 over 180, it's going to give us a decimal. And typically when we're dealing with radians, we don't really write them as decimals. We usually keep them as fractions. So if we want to tell our calculator, hey, if we want a fraction instead of a decimal, we always click these arrows right above enter. So that's 1/5, right? So 36 over 180 is 1/5. And we kind of ignored that pi when we were doing this, so we're going to put that pi back. So our final answer would be 1/5. And when we have 1 times something, we don't really have to write that 1. So pi/5 would be our final answer there. Okay, on letter B, same idea. If we want to get rid of degrees to have radians, we want degrees on bottom and radians on top. So our degrees will cancel. And now we're left with 540 times pi up top and 1 times 180 on the bottom. Same idea. We're going to go to our calculators and figure out, well, what would these simplify to? And then we'll put that pi back. So 540 divided by 180 is 3. 3, and we'll put that pi back, 3 pi. So you guys are going to take a second to practice converting. These are some of our values that are actually going to be on our unit circle. So take a minute and see if you can convert 30 degrees to radians, pi radians to degrees, and you have an answer bank up here to help check your work. Okay, so take a few minutes. I'll put up answers in a second for you to check. All right, so these are the answers that you should have gotten, hopefully, converting back and forth. So if you didn't get these, make sure that you're trying to fix your mistake, you're asking a teammate maybe, or you're writing down a question that you can ask tomorrow for help. All right, so on our next page, we have another unit circle, and I already went ahead and wrote in all of our tangent values that we figured out the other day because we're gonna need that in a second when we start finding sine, cosine, and tangent values. So I would recommend that you go ahead and either copy them straight from here, or you go back to, I think it was page 11 where we had our unit circle. Yeah, page 11, and make sure you understand where all of these tangent values sort of came about from. So what I'd like you guys to do on this page is we already did some angles on our unit circle up here that we converted back and forth with. I want us to do the rest. So for example, I want every single angle in degrees here to now be our radians, so that we can have 2 ways to measure that same distance. So take a few minutes, fill that in, and then come back and check when you're done. All right, so make sure that you've checked your work. We already kind of went over our quadrantial angles yesterday. We know a full circle around is 2 pi, so half a circle would be pi. Half of that would be pi over 2. Half of this distance would be 3 pi over 2. So make sure that you get all of those written down. Okay, last thing that we're gonna do is use this unit circle to help us find some sine, cosine, and tangent values, just like we did the other day with degrees. So very first thing that we're doing is we are finding cosine of 5 pi over 3. So we're going to go up to our unit circle and we're going to search for 5 pi over 3, which is right here. And we wanted our cosine value. So remember, cosine is always going to be our x, right? That's our cosine. And our y is always going to be our sine. So if we want cosine, our answer here is just 1/2. Right, we'll do the same thing for a sine of 7 pi over 6. So we'll go up to our unit circle, search for 7 pi over 6, which is right here. We wanted our sine value. That's our y, so negative 1/2. Last but not least, for at least A through C, we have tangent of 5 pi over 4. So again, go find 5 pi over 4 on our unit circle. It might take some searching at first for you because we're not super familiar with where all of our radians go. But the more practice we get, the easier it'll be to spot. So 5 pi over 4 is over here. And our tangent value we said is 1. Remember, we get our tangent value by doing y divided by x. So since it would be the same thing on top and bottom, we would get 1. All right. The reason I said last but not least before is because D, E, oh, those letters are wrong. This should be an E and that should be an F, shouldn't that? D, E, and F are a little bit trickier because we could search the unit circle forever and ever and ever, but we're not going to find any of these angles on there. They're all going to be either too big or too small. So just like what we did when we had degrees, let me scroll back, and we had something that was too big or too small, just like this one. We needed to find a coterminal angle, meaning this was too small, right? Negative 90 isn't on our unit circle. We needed to make it bigger. So we had to find a coterminal angle by adding 360. And this represented us going in a full circle. It's going to be very, very similar when it comes to radians, except that we're not going to be adding or subtracting 360 anymore because that's not a full circle in radians. A full circle in radians now is 2 pi. All right, so one full circle in radians is 2 pi. So that's what we're going to use to add or subtract. So 13 pi over 4 is too big. So we need to take that and find a coterminal angle, right? We'll subtract 2 pi to make it smaller. If we want to subtract fractions, remember we need a common denominator. So if this is really over 1, our common denominator is going to be this 4. So what would we have to do to turn that 1 into a 4? Multiply by 4, right? And if we do something to the denominator, we have to do the same thing to the numerator. So 13 pi over 4 minus, this is now 8 pi over 4. Now we can add those, and we get 5 pi over 4, right? And so we can go to 5 pi over 4 now, which is right here. And that's in the exact same position as our 13 pi over 4, right? They're coterminal. They land in the same spot. We wanted our cosine value, so we're looking at our x. Our answer would be negative, where can I put this? Negative root 2 over 2. That would be our final answer there. Okay, same sort of thing is happening here, right? We could keep looking and looking and looking on our unit circle. We're never going to see a 23 pi over 6. So that's too big. So same idea. We're going to take that 23 pi over 6 and subtract 2 pi. But we need a common denominator. So if we multiply numerator and denominator by 6, that would help, right? So 23 pi over 6 minus 12 pi now over 6. And notice how 12 over 6 would still reduce to that 2 that we had before. So 23 minus 12. Oops, hang on one sec. 23 minus 12 would give us 11 pi over 6. And so that means that these two angles are coterminal. They're landing in the same spot, which means our sine, cosine, and tangent ratios are all going to be the same. So let's go back up to our unit circle, find 11 pi over 6, and we were being asked, I believe, for our tangent. Yep, our tangent value. So at 11 pi over 6, our tangent was negative root 3 over 3. Okay, same idea on letter F, right? This is actually going to be too small. Notice how it's negative. We don't have any negative angles on our unit circle. So instead of subtracting 2 pi to this, we would want to add 2 pi. So again, find a common denominator, right? Multiply top and bottom by 3. So we end up with negative 16 pi over 3 plus 6 pi over 3. And when we add those up, notice how we still get something that's negative. So even though we did find a coterminal angle here, it's not really going to be that helpful because we're still not going to find this angle on our unit circle. So let's just add 2 pi. Again, right? We already converted that. That was 6 pi over 3. So when we do that, we get negative 4 pi over 3. Still not on our unit circle, right? So we can add 2 pi, which was the same as 6 pi over 3, one more time. And that would give us 2 pi over 3. We can stop here because now we have a positive angle that we can go and find on our unit circle. Before, even though we found a bunch of coterminal angles, they weren't very helpful because they weren't numbers that we could go and find. So we're at 2 pi over 3 now. And we can go just find our sine value. So 2 pi over 3 is right here. And our sine is root 3 over 2. So that would be our final answer. All right, so you're responsible for trying these last 6 problems. If you want to check answers, I will bring answers tomorrow, but just do the best you can on here. And then when you're done, the only other thing that you're working on today is homework 5. So make sure that you've written down any questions that you're confused about. We'll go over them tomorrow. Have a wonderful day. I'll see you guys later.